want to talk about computer systems. You know, computer systems are everywhere. We use them at school, at work, and at home. We send emails, watch videos, play games, and even pay bills online. But have you ever thought about how a computer really works? How it can calculate, store information, and connect with other computers? A computer may look simple from outside, but inside it has many parts working together. In this talk, we will talk about four main parts: CPU, memory, data, and networks. I will explain them step by step and give examples so you can understand easily. Central Processing Unit. The CPU is like the brain of the computer. It does all the calculations and makes decisions. Inside the CPU, there are two main parts. The ALU, or arithmetic unit, logic unit, does math operations like AND, sub, multiply, divided. It also does logic operations like equal, greater than, or less than. The central unit tells the computer what to do step by step. It sends signals to other parts, like memory or input devices. For example, if we calculate 1 plus 2, the CPU gets the number and ALU does the addition, and the result is sent to the memory or the screen. A register is a high-speed storage unit within an embedded processor or peripheral devices used for storing data. Essentially, it is a circuit composed of flip-flops and can store a small amount of data, typically 8 bits, 16 bits, or 33 bits. RAM, ROM, or cache is memory. Memory is where computers store programs and data. Main memory is RAM, random access memory. It stores instructions and data. While the CPU works, there are two types. SRAM is very fast and used in cache. DRAM is slower and needs refreshing. ROM are read-only memory, storage fixed instructions to start a computer. Cache memory is very fast, and near the CPU, L1 is the fastest, L2 is medium, L3 is slower but bigger. Cache helps the CPU work faster. Secondary memory is for long-term storage. It includes hard disks, SSDs, flash drives, and cold storage. SSDs are fast, quiet, and save in energy. Hard disks have large capacity and are cheaper. Data representation: binary, bits, bytes, and logic gates. Data in computer is in binary. Binary use 0 and 1. Each 0 or 1 is a bit. 8 bits make 1 byte. Computers use logic gates to do calculation, AND or NOT, and XOR are common gates. They work with true or false values. Characters are stored using codes. ASCII is for English letters and symbols. Unicode can store characters from all languages. UTF-8 is common on the web. Networks: how computers connect. A network connects computers and devices so they can share data. Hardware includes network cards, routers, hubs, and switches. Software includes network operating systems and protocols. TCP or IP is the most common protocol. Network topologies show how devices are connected. Bus: all devices share one line. Ring: device from a circle. Star: all devices connect to a central hub. Tree: hierarchically easy to manage. Mesh: devices connect in many ways, very reliable. Networks let people share programs, printers, and data. They also make communication faster and help backup information. In calculation, computer systems include CPU, memory, data, and networks. The CPU calculates and controls operations. Memory stores data temporarily and permanently. Data is in binary, and networks let computers communicate. We use computers every day, and now you know how they work inside. Thank you for listening.